Today we'll be looking at derivatives of exponential functions. To begin, let's start with a simple exponential function y equals b to the power of x and try to find the derivatives using first principles. So recall our first principles is when we're looking at the limit as our h approaches 0. So we're going to have our f at x be equal to b to the power of x, and our f of x plus h equal to b to the power of x plus h. So to find our derivative using our first principles, we use the limit as h approaches 0 of f at x plus h minus f at x all over h. So that brings us back to looking at derivatives from Unit 1 and a little bit in Unit 2 as well. So we're going to sub in for our f at x plus h and our f at x. So we have b to the power of x plus h minus b to the power of x all over h. We then can simplify this a little bit further just by our exponent rules. I know b to the power of x plus h is actually just b to the power of x times b to the power of h minus b to the power of x all over h. So now what we're going to do is we can factor out a b to the power of x, and we'll be left with b to the power of h minus 1 all over h. And we can go one step further by using our limit rules, and therefore f prime of x is actually equal to b to the power of x times the limit as h approaches 0 of b to the power of h minus 1 all over h. So just let's look at what f prime of 0 is. F prime of 0 is equal to the b to the power of 0 times your limit as h approaches 0 of b to the power of h minus 1 all over h. Anything to the power of 0 we know is actually just 1. So any constant will always be equal to 1. Even variable, anything to the power of 0. So I'm left with f prime of 0 is equal to the limit as h approaches 0 of b to the power of h minus 1 all over h. So therefore, we can finish with if f at x is equal to b to the power of x, then f prime of x is equal to b to the power of x times f prime of 0. So therefore, overall, f prime of x is equal to f at x times f prime at 0. So now I'd like you to pause the video and analyze f prime of 0 equals the limit as h approaches 0 of b to the power of h minus 1 over h for different values of b. When you're doing this, use h to be equal to 0.0001 and determine the limit for b equaling 1 to 5. After you're done that, you can resume playing of the video, but I would expect that the 5 questions here would be done. After analyzing the part before about your f prime of 0, you notice that the b value that you get is equal to 2.718. That allows your f prime of 0 being equal to 1, so that the limit as h approaches 0 of b to the power of h minus 1 all over h is equal to 1. So let's just talk about that number. So the exact number which makes f prime of 0 equal to 1 is given by the symbol e, after the mathematician Euler. So e is just equal to 2.718281828 and so on. It is going to continuously repeat itself. So if we're talking about a function such as e to the power of x, then f prime of x is actually just going to be equal to e to the power of x. So this only happens when you have your f at x being equal to e to the x. Still always use our regular derivative rules if we are dealing with something such as x or x squared or 3x and so on. So let's look at an example of this. So we want to find the derivatives of each of the following. So we know from above here that anytime we have f at x equals e to the power of x, our derivative of that is actually just e to the power of x. So we want to find the derivative of f at x equals x squared e to the x. So this is where we will use our product rule. So f prime of x will be equal to 2x, since that's the derivative of x squared, e to the power of x, plus x squared e to the power of x, since that is the derivative of e to the power of x. Here we can factor out a x e to the power of x, and what we're left with is 2 plus x. We can't go any further than that. Now what about b here? Well, b, we are going to take the derivative of g to the power of x, and what we're going to do, since we know that e to the power of x is actually just, the derivative of that is just equal to e to the power of x, we're going to have e to the power of x squared minus x. Now this is similar to when we were taking our derivatives. We then take the derivative of the exponent. So you multiply by 2x minus 1. Now we don't need to expand here. That is as far as we can go. So in general, if f at x equals e to the power of g at x, f prime of x is going to be equal to e to the power of g of x times g to the prime of x. So now let's take that rule and do example 2. So given f at x equals 6 e to the power of x squared, determine f prime of -1. So our first step here is to find the derivative of f at x. And what that's going to be, 6 is just a constant, so you don't need to take the derivative of that. So we just have 6 e to the power of x squared times the derivative of the exponent, so times 2x. So I can multiply the 6 and 2, so I get 12x e to the power of x squared. Now we need to find what f prime of x is equal to at -1. So we're going to sub in -1 here. So e to the power of -1 squared, 12 times -1 is just -12. E to the power of -1 squared is just 1, so it's just going to be -12e. Now this is exact. Now for graphing purposes, you would want to know what the actual number is. So with your calculators, you do have an E button. Everybody should have it anyways. If you can't find it, please come see me, but you should be able to find it. A lot of times you'll need to use your second derivative to use the E button. So this number, when you multiply -12 times E, which even if you didn't have the E button, you know E is equal to 2.718 and so on. So this becomes -32.619. So this would be used for graphing purposes. So if a question were to ask just to solve it, please leave it in our exact form. So now in example 3, we want to determine the equation of the line tangent to the graph y equals x e to the power of x at the point where x is equal to 2. Now, this goes back to working with this in previous units, that when we are looking for the equation of the line tangent to the graph, our first step is to always find the derivative of our function. So y prime is equal to e to the power of x plus x e to the power of x. One other thing that we need to know too is we need to know what the derivative is equal to at our given point. So we find our y prime of 2, which is equal to e squared plus 2e squared. So that will be equal to 3e squared. Because e squared, that is actually like terms, so we're able to add 1 plus 2 to get 3. Now what does this tell me? So remember, this tells me my slope. So in number 2 here, second step, we have our slope is equal to 3e squared. Now another thing we need to know, at x equals 2, what is y equal to? And y, we can sub in 2 there, is equal to 2e squared. So using this information, we can then use y equals mx plus b, and we can sub in our slope, and we can sub in our x and our y to solve for b. So we have 2e squared is equal to 3e squared times 2 plus b. So then we have 2e squared, so I'm going to skip one step here. 3 times 2 is 6, and when we bring it over to our left side, remember it becomes negative. So minus 6e squared is equal to b. So b therefore is equal to negative 4e squared. So now we have our b value, we have our slope, so therefore y is equal to 3e squared x minus 4e squared. Now if we didn't want to have our e squares, or we were actually having to graph this, we would have y is equal to 22.167x minus 29.56. In our last example for this lesson, we want to determine the equation of the line tangent to the graph y equals e to the power of x over x squared. X here cannot be equal to 0, because if x were to be equal to 0, obviously our function wouldn't exist at the point where x is equal to 2. So we're going to follow the same steps as our previous example. So number 1, we want to find the derivative of y, which is equal, we're going to use a quotient rule here, e to the power of x times x squared minus e to the power of x times 2x all over our denominator squared, so x to the power of 4. And then we also need to know at our point here, because that point will then allow me to have my slope at 2. So e squared times 2 squared minus e squared times 2 all over 2 to the power of 4. So this becomes 4e squared minus 4e squared all over 16. So therefore I have a slope of 0. So we have a slope of 0, and at x equals 2, y equals e squared over 4. So we just find that by subbing it into our original function. Third step, we have y equals mx plus b, so let's sub in what we know. We know our slope, We know our x value, we know our y value. So we have e squared over 4 is equal to 0 times 2 plus b. So therefore we have e squared over 4 is equal to our b. So therefore y is equal to e squared over 4. And that tells me also that y is equal to 1.847. So since we have a y value, that tells me, and it's just y, we don't have a slope, tells me that we have a horizontal line.